Hello there, let's talk about rape statistics and using actual science to demonstrate why they are wrong. I'm sure by now we're all familiar with the age-old 1 in 5 women will be raped at some point figure that was coined by Mary Koss in her pseudoscientific research. I'm sure most people are aware of how and why Mary Koss's numbers are wrong, but I will give you a very brief overview. The gist of it is she surveyed a bunch of university students, and based on their responses, she or one of the other people conducting the surveys determined whether or not that person had been the victim of rape, regardless of whatever the respondent to the survey actually said. So they ended up including in their category of raped a bunch of people who actually had consensual sex. This may include sex while alcohol was involved, which may sound bad at first, but then you realize it could include things that are relatively innocuous, such as you went out for a lovely meal with someone, there was a glass of wine on the table, you drank it, and then you came home and had sex with them. Not exactly rape, but it could easily be put in that bucket by ideologically biased researchers. Koss and her researchers also ignored crucial details, such as about 1/3 of the people that they claimed were raped went on to have relationships and even marriages with their supposed rapists, which probably indicates that it wasn't unconsensual. But today I'd like to use some different science to demonstrate why the 1 in 5 figure, wrong as it is by their gathering method, is actually correct, but not in the way that they think it is. So this is going to be debunked twice in a second way, completely differently, that actually shows that the 1 in 5 figure is right, but also totally wrong. So this might be a little more fun, I suppose. In order to do that, I'd like to briefly introduce you to something called leverage saliency theory. And the reason I'm going to use this theory and this example is because it's something which I brought up a few times before online, but I've never done a dedicated video for, and it is something which I actually use in teaching as well, because it's quite useful as a kind of a lies, damned lies, and statistics example. It really shows how you can make data say whatever it is that you want to say if you do things such as ignoring control groups, for example, which we've seen numerous feminist researchers doing, or social justice inclined researchers, critical race theory observers and researchers, whatever you want to call them, they're all basically the same thing. So when it comes to surveys and getting people to take surveys, we have something called leverage saliency theory, which we need to apply to that. Now, leverage saliency theory is an observation that people effectively have a threshold at which they will take surveys, because as we all know, taking surveys kinda sucks. You're having your time taken up by someone trying to gather information for something that you're probably not actually that interested in. And so researchers have found over a number of decades that in order to get people to actually take surveys, especially surveys that they might not necessarily be that interested in, we have to leverage their interest. We have to give them something a little more interesting. And one of the primary ways of doing this is turning it into a kind of tit-for-tat sort of game theory exchange, whereby you give me this piece of information and I'll give you something, such as a financial reward. This can either be cash money, or it can be like a coupon or a voucher redeemable for some value or some item somewhere, whatever. That increases people's likelihood of taking a survey. And the way that we envision this, the way that we draw it out, is basically as a seesaw, which gives us a sliding scale from 0 to 1. So if a person scores 0 on this scale, they are not going to fill out their survey, they don't care, it has no interest for them, they're just not going to do it. If the score is 1, that means that they are going to fill out the survey because they have some sort of interest in it. And interest there is something which is quite important. People tend to fill out surveys that they are interested in some capacity. So for example, if we had a survey regarding something like, say, pets or pet food consumption or something like that, well, only the portion of the population that owns pets might be interested in filling out such a survey. So if you went to a shopping mall and about 1 in 5 people had a pet, you would expect only about 1 in 5 people to have any degree of interest in filling out such a survey. But on top of that, you've only got this sort of 1 in 5, about 20% of people who even have an interest in that. Well, we may need to grease the wheels a little bit even further, and that's where our financial incentive comes in. So back to our sliding scale seesaw that we've got envisioned as going from 0 to 1, this sliding scale. What we do when we offer these incentives to people, usually again cash money or something like that, is we are effectively putting our thumb on one side of that seesaw. We're putting our thumb on the scale and pushing it more towards the number 1, which is the number that we want because we want information. We need our data because we need that information to do whatever it is that we're going to do, market research or generating some sort of report on customer footfall or basic psychological studies, whatever it is that we're doing, we want that information. So we've got to find a way to get it. So if we can put things of interest on our side of the scale to tip it in our favor, we should absolutely be doing that. And knowing this one particular theory is the thing that demonstrates why the 1 in 5 figure is wrong. So the figure of 1 in 5 women will be raped in their university thing, which it was originally for university. It sometimes is cited as lifetime prevalence and things like that. The number just gets kind of butchered around the place quite a lot. So we've got that, which is 1 in 5, which is 20%, versus the known base rate of criminal reporting, which is usually around 1 to 4%, something around that for lifetime prevalence. So there's this very large disconnect between these two numbers. Well, we have to explain this disconnect somehow, surely. We can chalk it all down to the terrible methodology of people like Koss, the pseudoscientific researchers that they are. We can absolutely do that, and that's certainly one way of pointing at their supposed evidence at their studies and invalidating them immediately. But we can also use other theories, such as leverage saliency. So, for example, one of the things that we note about Koss's research is that the response rate is only about 20%. Now, that's very interesting by itself, because you'd look at the other 80%, and using something like leverage saliency theory, you would say that, well, the 80% of people that didn't fill out this survey, they simply had no interest in filling out this survey. They are neither the victims of rape nor sexual assault. They don't know people who are the victims of rape or sexual assault. They probably don't even know people who are the victims of rape or sexual assault. So there is no incentive for them to interact with your survey at all. So when you take this 20% response rate, which gives you this 1 in 5 figure, well, we can multiply that 20% up to fill the 100% which we actually need. So we've got this 80% who effectively have the response no, as in there's no interest, there's no reason for them to do so. So if we take our 100% and we instead turn that into 100 people, well, they've got their 1 in 5. So let's multiply that up until it forms 20. So 1 in 5, and then we multiply that up 10, 15, 20. Oh, okay, well, that gives us 4. So we assume that the 80%, which is our 80 other people, didn't respond because they have no interest in it. So this actually multiplying it up gives us a response of 4 in 100. So that's 80%, 80 people for which the answer is no. Of our remaining 20%, 1 in 5 of them, we multiply the 5 up to 20, which is quite obviously 1, 2, 3, 4. Okay, 4 times 5, 20. Well, there we go. We've filled it in. That's where we've got our 4 from, because 1 in 5 is the same as 4 in 20. We've just scaled it up. So our 1 in 5 figure, which is incredibly erroneous in itself, simply by the use of leverage saliency theory, we have demonstrated is 4 people in 100, which is 4%, which is about the same as the national average. Maybe you could make the argument that 4% is a little bit higher than the national average, since a lot of them tend to float around 2 or 3%, but you could easily chalk this up to saying, well, if the average is about 2 to 3%, some areas are going to be a little higher than that, some areas are going to be a little lower than that. This may very well just be one of those cases where it is very slightly higher. It could also still just be an artifact of the absolutely atrocious gathering method that Koss used. Because keep in mind that 4% is still subject to their ridiculously expansive inclusion criteria. But all in all, it's still about the range that we would expect. And you get to this conclusion by using actual social sciences, as opposed to the bastardized pseudoscientific form that far-left activists use.